Hello students, we are back in our discussion about the transformation, and so far we have discussed two types of transformation. We have seen how the object can transform by translation and also by rotation. So I've done something about the translation and also the rotation. Please remember what is involved in translation, right? How do we translate an object? This simply just we're talking about the talk of the change of position, what is involved. So remember what we highlighted initially about the talk of the column vectors involved, how we come up with that, and how that vector translates an object. And here in the rotation, all those points that I highlighted and what are also presented in the discussion here, issues about the center of rotation, talk of angle of rotation, direction of the rotation, clockwise and clockwise. Let all of the issues be revised by you and be able to know, because the only guide that can help you to do the transformation of that kind, rotation and translation. Right, so without wasting much of our time, today we're going to pick up the last type of transformation. This is something that has to do with enlargement. Right, so we are going to do issues about the enlargement. Right, now, as we did with the transformation and rotation, we are here, first of all, going to at least discuss what it is about enlargement. Then we're going to take ourselves through about the activities that we need to know. Each time maybe you're asked in the exam how to enlarge an object, you should be guided by what we're going to discuss here. Right, so first allow me to define a transformation defined by enlargement. So enlargement. All right, definition of enlargement in mathematics is going to be different of what we know in English, right? Generally, enlarge is just to change the size of a figure. So simply here, if we talk of to enlarge, it simply means to change it. That's a talk of what? Size, or simply just change up what? A figure. Right. How can a figure change? In terms of size, that is what matters most in mathematics. Right, in English, literal translation of the enlargement simply means a change of size to a larger one. A small size object increases in size, or something that is large now becomes huge. But in mathematics, enlargement is in two folds. Any object can change accordingly. It can increase in size or reduce in size, which to you might be very surprised. How can something that is big now becoming small in size? Enlargement. Our case in mathematics, that's it. So we talk of a change in size in terms of an object which is small, and then comes up to be what? Large. It's just like magnified. Or else an object that is large, and now you are there going to reduce into small size. So it means large to small. Thus, enlargement in our case. At least we have to see just a change in size of an object. Thus is enlargement. But in your English, we just talk of the smaller to large. So please let us try to understand one another here. So we'll be there looking at it to say, how do we increase the size of an object, or else how do we reduce the size of an object by this definition that we have it here. Right. Now, let's now first of discuss the issues that we'll always be able to notice every time a figure is enlarged, either by increasing or reducing the size. Say, for example, they might give you a triangle of a certain dimensions, and they'll ask you to enlarge that size either by reducing or by increasing its talk of the dimensions. Right, an object like, say, for example, a triangle, this one here, if we can enlarge this triangle by increasing its size just by sketch, tentatively, we should expect something to be a little bit huge like that. So it means I may have like triangle ABC here, and here it means if this is the result of enlarging this one, we would find this one as an image, while this one, the initial object is defined, the initial triangle is defined as what? Object, by what we have already discussed in the first types of the transformation. So it means this vertex here will be defined as A prime. This is just the image of A. And now B, this one, that is the object. The image of this one, it will be this one here. And this is the image of point C. So the result of transformation is what is known as image. So if this one is enlarged to increase its size, then it will be something like this. Now, let's first of all discuss what is it that we should expect when an object has been enlarged. Right. One, what you have to know is just like as you enlarge, it doesn't mean that you are changing the shape of an object. No, it's only the size that is affected. So what you should expect is that the two objects, considering the object itself and the image, these two, if we are going to compare, we'll always find that the two figures are similar. Right. Always, when you enlarge an object, the result is an image. You compare the two images and the object, they'll always be similar. So if they're similar, then what should we expect then? It means the corresponding angles must be equal. An angle that corresponds to B in this case for the object in the image, it is this angle here that is prime. So if this angle is maybe 60 degrees, you should also expect that angle should be 60 degrees. The same, this angle here corresponds to this angle here. You can see here this A, this is A prime. This prime is just a result of transforming this A. So that is the image. So this angle here must be exactly equal to that one. If I indicate this one, that is at x1, this one is x2. This is y1, this one is y2. And this is m1, this one is m what? M2. Things like that. So let us try to notice that. A situation about enlargement, it goes like that. So we are talking about what? Corresponding angles must be equal. The other thing is about the corresponding sides, nature of the corresponding sides. So here we're referring to, like, say, for example, if we talk of the object here, we have got side AB. This AB corresponds to what? A prime, B prime. So you talk of side AB, this one, versus A prime, B prime. And also we talk of that says side BC, versus B prime, C prime. And lastly, we have got side AC, which is AC versus A prime, C prime. Right. If you're going to compare these two sides, you'll always be able to see that those sides, the pairs of those sides, corresponding sides, they'll always be parallel to each other. So this is the symbol for parallel. You should expect AB to be parallel to A prime, B prime. And also BC is parallel to B prime, C prime. And again, to talk of AC is parallel to A prime, C prime. If we are there going to, at least going to enlarge an object. It doesn't take to say the object is bigger as compared to the image. It doesn't look at that, but you should expect at the end, the figures must be similar, corresponding angles must be equal, and lastly, we talk of the corresponding sides of the two figures must be what? Parallel to each other. That parallel to that, that parallel to that, that parallel to that one. Up. Right. Now, before we go into the now points to consider when enlarging a figure, let us first of all discuss how, in one way or another, that figure can be enlarged. Right. Maybe let me begin just giving the guidance on how we enlarge a figure and what is it that we expect. Right. So these are the issues about the status of the image and the object. Now, let's take the other side of the story, the points to consider each time would like to enlarge a particular figure. Points to consider. Right. They're just issues that you should understand, that the language of which will never cease from your mouth each time we talk about the enlargement. One, very important, you have to know the center of enlargement. Right. It means an object or a figure can be enlarged with the center of enlargement. So what is the center of enlargement? Secondly, you need also to know something about what we call the scale factor. A scale factor, very important. This one is something that has to do with the size. By how much have you enlarged an object? Is it twice as much? 3 times as much? 5 times as much? Maybe half times as much if we're going to the reducing side. Increasing side, is it 3 times as much? That is what is defined as what? A scale factor. So we're going to discuss this one in the first example that will give you to you, right? And be able to see when talk of the center of enlargement, what exactly it is about it. Right? What about the scale factor, what it is, and how does the two determine the that's the talk of the enlargement process. Right. Having known that, let's also realize that whatever we're going to do here, we should expect to have our scale factors in any one of 2 folds. Right. It won't learn from that. Firstly, the scale factor that we're going to get can be that is greater than 1. So it's more like the scale factor here is compared with a 1. Remember, if you are going to enlarge something once, I don't think it can change the size. You have magnified something once, or so you have increased something once. I don't think 1 can change anything. So a scale factor of 1 is meaningless. The subject does not change. But if you talk of a 2, it means that something is doubled. You are doubling the size. 3, it means something is what? Tripled. Half, you talk of something is being reduced. But 1, it means the object is the same. It means enlargement is not done. So whatever we should expect about scale factor is either to have a scale factor that is above a 1 or below a 1. Right. So if it is greater than 1, if the scale factor is greater than 1 or above 1, we should expect the image to be greater than the object. That's the initial figure, if the scale factor is above 1. And if the scale factor is less than 1, the opposite is true. We should expect to have the image to be less than the what? Object. Object is the initial figure you are enlarging. So these are the expectations. And another some point in time, we can also expect to have a scale factor that is negative. Negative. Right. We're going to discuss on how we can find these scale factors. Of course, I've already defined it to say we are just taking to say how many times are you going to enlarge an object? Is it twice as much or half as much? And what have you? Right. So a scale factor sometimes can be negative, -2, -3, -half. So if a scale factor is negative, like -2, etc., our expectation is that when I'm enlarging the figure, I should expect to have each above the center of enlargement to be in between the image and the object. So for the others, a positive 1, these are positive, greater than 1, less than 1, we're not talking of negative here. It means the center is always away, it's not in between the 2 figures. It's either to the right, or say it can be to the right of the image, or say to the left of the object. Right, but now it is negative. you have a situation that looks like this. Look at this. If this is your image and this is your object, so which means your image is more like, again, upsetted. It will be upsetted like this. If this is your K will come like this one, that's K prime. If this is your T will come here and T prime. And this is your F will come like that. As such, the center will be in between the object and the image as such. And lastly, apart from having the center in between the object and the image, for the negative factor, you should also expect the image to be upside down. It should be upside down as such. Right, so the points which I've just highlighted here can just be repeatedly being revisited by keeping on replaying this video backwards play now and again and try to understand what statement I'm trying to produce here and how worthy are they in our discussion here. So please, students, try to first of all get to know what is there to be considered in the enlargement process and what are your expectations, so that every time you should have a knowledge about it, not only just say this is the way we do. No, mathematics don't go by that. Try to understand your expectations and why things are done that way. So please take note of the points, very important. And again, talk of the expectation. If your center, if you talk of the scale factors negative, what do I expect? I expect the center to be in between the two figures, object and the talk of the image, and the nature of the image must be upsetted, while the other story is always true. Right, so having done this, I think it's now worth it that now have to do the activities at large, where we have to see everything which I've highlighted here in the introductory part has to be observed. Meaning without them, I think what we're talking here does not exist. Right, so let's have the first example and now try to understand exactly what is this center of enlargement that we're talking about and how do we obtain it. Say, for example, somebody talks of it's in between. Maybe it can be on the other side, things like that. So firstly, what I'll do, I'll give you just a tentative simple example, direct one, where we're just going to enlarge a certain right angle triangle and see how it works. And out of what I would do here, we need also to obtain the scale factor. So you need also be able to know how to find that scale factor, given the two figures, the image and the object. Right, because it's just like I've just explained, but exactly now on the ground, what is it? Right. So let us take this way. I have my triangle here. Suppose I can have a triangle, and you can draw your own figure if you want. You can have a hexagon, you can have any kind of polygon. I would prefer to have my triangle. So you too should also have a page where at least you can script something. When I do, you do. I think that's where you can understand other issues much better. It's not just a matter of listening where you are. Try to have a pen with you. So let us draw a triangle which is right angled at one point. So it means just a sketch. So bear with me. But in your case where you are, at least you can relax and do things exact, following my explanations or the procedures. So here is my right angle triangle at, let me describe it, KTH. Right. So somewhere there's a point that the body is not all that enough in terms of space. It's not spacious. So allow me to erase this one so that I have to have a large space here. And maybe I should just reduce the size of the triangle to something like this. Let me consider this is my triangle. Right angle triangle. Right angle, that one. Talk of the KTH and whatever description you can have it. And somewhere, fix a point outside the triangle, anywhere outside here. Or maybe you can have somewhere there. Let us have it toward this side of this figure. Let me have it here. Right. And take that one as point N. Okay, point whatever. N or O. Now, you'll be asked to do this. Look at this. Sometimes even in the exam, they can give you a figure like this one, and they set a point somewhere like N. They will ask you to use, that's the N, to enlarge. That's the talk of triangle K, T, H. Twice as much or 2 times as much. Right. So it means whatever dimensions I have in that triangle should be 2 times as much. To mean that K, the length of KT should be doubled, length of TH must be doubled, and also length of KH must also be what? Doubled. So just like now, how can I double the dimensions of this triangle? Right. So what we're going to do here is this simple activity, which I did not highlight. I wanted to explain it up in the actions. Right. Double as much, 2 times as much. Just indicate here, 2 times as much using N. So what we're going to do here is like when you are asked such type of questions and your direct question is presented like this, a point N, just know for sure that point is what will be defined as the center of enlargement. It's the point where we're going to start every action that will at the end lead into the resultant shape to be 30 times as much. Is it 5? Is it 10 times as much? So there's a point of reference, and that point is what is known as the center of enlargement. So let us see how that center really leads into having something that will be double as much. So what we're going to do is this. You are going to use that point by drawing the lines that has connect that point with all the vertices of that triangle. First, like say for example, K can come from N, and you do it like this. Then T will come from N, and you do like this. So I hope you are also doing the same there. And H will also come from N. But allow me that I have to draw this N down here, because if I leave it here, people will just see like I'm doing the same line. I don't want that. I want you to see exactly what I'm doing here is what. Fix another point should be down like this. I don't want you to have just one line connected by several issues there. So just have N here. Right, so the same procedures. We go, draw N to K like this, and then have T to N like this. Then draw H to N like this. Right, you see how I'm using this point here? It's the same point. Look at this. So I think the first procedure is picked. I have my triangle. I have got my point. I'm connecting N to all the vertices. We have got 3 of them here. So if I'm now asked to enlarge this one, it's more like magnifying this one to twice as much. So my expectation is that this side should be double as much. Though I have not measured, but I should expect at the end this one should be twice as much. This one twice, that one again twice as much. So what we do is this. You look at this distance here, which is there connecting N and K. So it'd be just like now, when you enlarge this figure, what you should expect is that K, H, and talk of a T must be somewhere at a point here. Such that when you're going to connect those points are the same here, which will be regarded now just like images of K, H, and T. Those ones, when you connect, the result is another triangle, which would be of the same shape of this one here. But the sizes of the length must be enlarged. That's twice as much. So what you do here is just a matter of considering the distance from here up that. And this distance here has to be doubled. So it's just like we're going to produce a line double as much in NK. And that line will give you a new position of a K. So like for example, I'll have my ruler here and lay it like this. and I'll see that here, at least I'll see that is from here up to that. That is the length of my ruler. Now I would see that from here up to that, that's the distance I have. It means now the new position of K should be from here to double as much. We are referring to the center. So if I can talk of this one here, it means my new distance now, it will be like this one here. It go like that, where K will be, if I'm not mistaken, somewhere the K must be here. That is now the new position of K. Right. We are referring to the point of N. K is at this distance, but now if talk of a new K, which is K prime, because we say 2 times as much, we expect that from here up to that is doubled. So it's more like I'm going to draw a line from here up to that, that will go something like this. And I'll throw K at that position. The same, a new position of T, it will be like doubling this distance N to T. And where are we going to be? And that's the new position of a T. The same talk of H, the new position of H, somewhere there where we don't know. Just double this line 2 times as much. If it is 3, it means you have to triple. 4, you have to multiply that one 4 times as much. So for the T, NT, you have to measure this one here. But sometimes you can do better with a pair of divisor. But here, just to take that, say we are just doubling the lines from the point which is the center up to the talk of the object point as such. So I have got N to, this is T, this is the dimension, and this is the length. So from here up to that, it means mine now will come straight like this one. To have it double as much, it means somewhere here. You might be accurate yourself somewhere when you measure, but always whatever you do there, make sure that the distance from here up to that should be twice from here up to that. Like, so if you look up from here up to that, it's just as good as from here up to that, double as much. So this is my new position of, that is the point what? Point T, just an explanation. And talk of NH, you have to measure the distance of this one, how much it is, and then double it. And you have a position for that one out. So like here, I'll measure the distance from here up to H, which would be something like this. That is the position, right? So in this case, it needs to go further like this. So I'll have it at somewhere here. Let's have a line like that one. So this one should be at least placed somewhere here. Right. So what I'll do, I'll just connect H to that like this. Right. So this is my new position of H. So I'll write that one as H prime. Finally, let's connect K to T to have something like this one, and then T to H to have something like this, and finally we talk of K to H to have something that looks more like this. Right. And here, set the angle, which is just 90. So now, look at the activity which I've done here. And the compare, of course, we struggle because this is not necessarily drawn to scale, but you can do better. You're going to realize that, say, if you talk of the distance from here up to the object point K, this one is of a certain length. But now, if I talk of the distance now from N to K prime, you're going to realize that, say, this one is twice as much distance from here up to that. The same from here up to that. You'd find that this one is 2 times the distance one. Okay, this one from here up to that is 2 times the distance from here up to that. So just like if you talk of NT versus NT prime, this NT prime is 2 times NT. The same if I compare NH prime with NH, you'd see that if you talk of NH, this one gets into NH prime twice as much. Right. So when we're enlarging, that's the first point we consider. Right. Take the line from the point, fixed point to that object point, the same to T, the same to H. How much are they in terms of length? Then double them as much. If it is issue about it, doubling. Then you have the lines produced so that you have to have a new position of those points. So the that shape here that we have here is known as the image, and this one is your object. Right. So compare KH and K prime H prime. You're going to realize that this side is corresponding to this. Those sides are even looking by themselves to say they are parallel to each other. These lines must be parallel. And if I look at K prime T prime versus KT, these are corresponding sides. They all go toward the same direction. And this one is heading toward this one is also heading to that one. That's what we meant earlier when we say corresponding sides of the image and the object are parallel. We're talking of that situation here. This is parallel to this is parallel to that, and this is parallel to this one here. The angles too, corresponding angles being equal. This angle is equal to that, this angle is equal to this angle is equal to that one. You can even just measure by using a protractor. This one I have here. You can just do it. What is the resultant angle here, angle there, angle there? You're going to realize that the angles are just what? Equal in length. Center of enlargement. Center of enlargement is the point where you find that the lines which are connecting the object point C and the image point T for KT, T and T, H and H, those lines where they intersect. So just take the line K, T, KK, HH, TT, when they're extended, obviously they're going to intersect at this point here. If you produce them, they're going to intersect here. Definitely they're going to intersect there. The point which you studied up, only that here gave you the pointer such. You extend this line, it goes like that. This one is going to pass through that. This one is going to pass through that. So this is your center of enlargement. Right. So you play the video now and again, or you can just have a back play now and again, so that you at least understand what I've explained here. So the actions which I've just done here are what are processed out as the enlargement process. So please remember how we have done this. Right. Let me just explain a bit on the issue about the scale factor. Right. Yes, we have said it is a 2. 2 times, number of times, an object has been enlarged. So now in case they ask you to find the scale factor, you don't know it, but they've just given you a figure like this one here. They say this is an object, this is an image. They may ask you, can you find the center of enlargement? Like this now, look at this. If you might not have this, what we have already indicated, but they'll just give you what? An image and the object like that. They'll ask you, can you find the center? What you do, you just have to connect K and K, you go like that. Then T and T, you go like that. You don't have to bother whatever will be happening down here. Just connect as much as you are given the 2. These are the kind of lines of questions. Just connect H and H, you go like that.